Marcus Pont is the CEO of Domin. He's going to be looking how metal additive manufacturing is enabling the development of groundbreaking active suspension systems. So we're going to be looking at how we can go about creating smaller, more energy-efficient hydraulic systems that can help redefine vehicle efficiency and performance. So, Marcus, thank you.
Thank you. Consider some of the advancements in technology that have transformed our world over the past 70 years. Computers have shrunk from the size of a house to the size of a watch. We've moved from a predominantly analog world to a digital one, from a rules-based system to a machine learning, AI-led, sophisticated digital world. And we've seen huge efficiency gains in everything from car engines to solar panels and more. Almost all of the technology around us has got smaller, faster, and more efficient. However, despite being central to almost all of the most fundamental industries that build our world, hydraulics have not advanced in the same way. Rather unbelievably, they still rely on the same clunky, inefficient products that powered the world in the 1950s. My name is Marcus Pont, and I am the CEO of Domin. We've been operating for about 12 years now, and we're on a mission to bring about positive change into the world of power and motion control, which to most people is hydraulics. Today, I'm going to talk to you about how this opportunity can be applied into the automotive industry, and why it is now that we must see a new technology revolution. And I will talk to you how metal 3D printing has helped Domin set the new standard in motion control. Hydraulics are everywhere. Hydraulics is an industry that underpins almost all others. We like to think of it as a capillary industry. It's a little bit like packaging. By itself, it doesn't bring value to the end user, but it facilitates so many other industries to generate value for the world. This means that it is both everywhere and nowhere at the same time. If I pause and think about the impact it's had on me, just on my journey from my home in England to be here in Frankfurt today, it's astonishing. It's used in the brakes in my car that drove me to the airport. It's used to control the wings, rudder, landing gear, and more in the plane that I flew across to Frankfurt. It's used in cranes and diggers that built this building, and it's used in the manufacturing of the computer that I used to make this presentation. Hydraulics are central to almost all the fundamental industries that build our world, and the automotive industry is one of them. And it's a great example where we can bring about positive change. Hydraulics really are everywhere, but that means they use an unbelievable amount of energy. McKinsey recently issued a report called Preparing for the Imminent Revolution in the Fluid Systems Industry. In that report, they estimated that fluid pumps alone account for 15% of all the energy used within the EU. Just think about that for a moment. Not aeroplanes, not constructions, not automotive, but an industry that's used across all of those areas, hydraulics. All of those industries use hydraulics, and fluid hydraulics accounts for 15% of all the energy used within the EU. But does it really need to be that much? As human development continues to advance rapidly, the demand for energy will inevitably increase. It serves as a crucial resource to fuel the progress that we want as a society. Being wasteful with energy results in industries losing time, money, and opportunities for improvements. Additionally, we're grappling at the same time with the trade-offs that are the result of global industrialization. But we have an incredible opportunity previously overlooked for all industries to fundamentally change how they approach energy. And we do really need to. Oak Ridge National Laboratory carried out a cross-sector, cross-market study, and they determined that the average hydraulic system is only 22% efficient at converting the energy in to the energy out for any given function. This means that within the EU alone, we're wasting approximately 4,300 petajoules of energy. That's the equivalent of the energy needed to power 82 million homes for a year. That's an incredible amount. During the last decade alone, we've obsessed, as we've just seen, about transferring from petrol combustion engines to EVs. And combustion engines are 40% efficient. And yet we have completely overlooked an industry that is only 22% efficient. The automotive market faces a growing sustainability challenge as cars become larger and heavier. The shift towards SUVs, driven by consumer demand, contributes significantly to this trend. These vehicles, which are often equipped with batteries and hybrid engines, demand more energy, are getting bigger, and demand more performance. Additionally, stricter safety regulations and increased technological features add more weight to modern cars. In real terms, the average weight of new cars in Europe has increased by nearly 400 kilograms over just the last 7 years. And the average curb size weight for a vehicle has increased from 1,550 kilograms to almost 2,000 kilograms. This escalating weight has a massive impact on comfort, performance, and energy consumption. It renders the current technology unsustainable. However, there is an opportunity to find solutions to make more energy efficient, higher performing, and more comfortable vehicles, whilst maintaining the industry preference towards SUVs. We do have an opportunity to change this, and we do have an opportunity to rethink how we can do more with less. Over the years, humanity has experimented with different materials, technologies, and methodologies to build the world around us. As time has progressed, various versions of these have stuck, and we call those stable technologies. A great example of this is the convergence on a stable technology within mobile phones in the 2000s. They initially varied in size, shape, and each functioning in their own way. Now, mobile phones all look identical. They look identical in form and function. Consumers now only get to choose between the smallest variety of differences between phones. However, over time, stable technologies can become stagnant, and new techniques can come along to promote change. Modern tools such as metal 3D printing, advanced electronic motors, sensors, and electronics present a significant opportunity to innovate and overcome the limitations previously of existing technologies. These advancements have the potential to establish the new stable technologies of the future and create systems that remain the same for the next 50 to 100 years. As a manufacturing tool, metal 3D printing offers the capability to create hydraulic technology optimized in ways that remain impossible using traditional manufacturing methods. Although it is a new technology, it is important to acknowledge that 3D printing is just a manufacturing process like any other, albeit one that can unlock many benefits. Apologies, I think this is meant to be a video, but it doesn't appear to be working. Great. It is only of printing, but hey, Printing looks cool. Metal 3D printing eliminates the design for manufacturing constraints inherent in subtractive machining, allowing for the creation of lightweight structures through optimized material distribution and the removal of excess material. This reduces the overall weight of the manufactured product and can result in improved energy efficiencies. Plus, the nature of metal 3D printing means that only the material that is useful to the final product is used, bringing further benefits to the size and weight of the product and the manufacturing process. Metal 3D printing makes it substantially easier to tailor components to specific applications or system requirements. The flexibility of the design and manufacturing process enables the rapid incorporation of design modifications, such as varying valve sizes, shapes, and flow characteristics for bespoke purposes across automotive applications. The benefits presented by metal 3D printing gives us an opportunity to rethink the design of hydraulic components with improved fluid dynamics and reduced energy losses. For instance, metal 3D printing manifolds and spools can be designed to optimize fluid flow, minimizing resistive losses and improving overall system efficiency. However, as you can see in these beautiful images, the art of complexity is often in simplicity. Once you've designed the complexity in, even the customization for specific examples, you're able to just print these parts over and over and over, just like any other industrial manufacturing technology. By returning to a first principles approach and redesigning hydraulic technology with innovations such as Hall effect sensors, metal 3D printers, and modern electronics, we can establish the new stable technology that will transform industries like automotive. The technology will set the benchmark for years to come. We can address the energy efficiency problem while still achieving the performance and precision required within automotive. We've utilized these opportunities to develop high-performance hydraulic technology, high-speed control valves, and ultra-compact pumps. We've enabled a complete redesign of hydraulic systems, pushing the boundaries of efficiency and performance. One example of this is our high-speed control valves, which are being used in vehicles to control suspension, vehicle dynamics, gear shift, clutch control, and more. By taking this first principles approach, by combining this with modern tools, we've been able to reduce the weight of the valve, reduce its cost, reduce its energy use, and increase the performance of the product. We've integrated multiple functions into a single component that enables us to operate the spool in ways that were never previously possible. Some of the benefits of these products are incredible. By using just one of Domin's valves to replace an existing state-of-the-art product, we can reduce the cost of energy of the use of the product by $400 a year, which saves approximately 1 ton of CO2 per year for every valve that we're able to sell. Traditionally, designing a radial piston pump involved navigating a complex set of compromises, particularly in managing high radial forces to ensure efficiency and reliability. The optimal solution is a pump pressure balanced along the length of its pintle. However, achieving this requires a highly intricate hydraulic commutation along the length and around the circumference of the pintle. Despite significant efforts in trying to achieve this over the last century, existing manufacturing technologies prevented us from being able to achieve this holy grail. Today, using the advantages provided by metal 3D printing and a first principles approach to design, we have developed a patent-protected radial piston pump that's able to be used within the automotive industry. When integrated into complex assemblies, we're able to bring substantial improvements in size, energy use, and performance. These two technologies have allowed us to efficiently generate hydraulic energy whilst maintaining a compact size and shape. By leveraging metal 3D printing we have developed hydraulic technology that is not only more efficient, but also higher performance and extraordinarily compact. I think this is also a video, actually, Alex. Hey, 2 for 2. These have led to us to be able to develop an innovative suspension solution. In our next generation hydraulic active suspension system, the high-pressure pump dynamically supplements suspension forces for extreme maneuvers, facilitating precise ride height adjustment with minimal handling power. High-speed valves paired with discrete accumulators allow us to almost infinitely vary the spring rate within the product. This allows us almost millisecond scale changes to the spring rate. This creates an intelligent, flexible system that achieves more with less. With just one application of this, we were able to prove that adopting this technology could reduce the amount of energy used within an automotive typical cycle by up to 10%. By recognizing, we're just testing to see if that was a video. By recognizing the enormous inefficiencies in today's energy use and rethinking the problem from a fresh perspective, we've developed solutions that significantly impact energy utilization within hydraulics and within automotive. These solutions allow us to combine valve and pump technology in various configurations, unlocking substantial benefits across the automotive sector. This can also be applied into industrial and aerospace applications. So what does this mean for automotive? The transformation of motion control, particularly within hydraulics, represents an opportunity to rethink the art of the possible from the ground up. It offers a profound revolution in efficiency, performance, and sustainability. Technologies such as metal 3D printing allow us to rethink what's possible. Within the automotive industry, it's time to rethink what's possible. Using metal 3D printing to print what is already possible to manufacture today in a different way is unlikely to bring the scale benefits that are required within automotive. We're completely convinced that metal 3D printing has the potential to operate at the scale required within automotive, generating millions of components per year. The challenge for the automotive industry, and hopefully what I've shown you is possible today, is to go back to first principles, rethink the art of the possible using technology like metal 3D printing to enable us to do things that were never previously possible. If we can achieve that, and if we can create enough value with the process, then there's an opportunity to completely revolutionize the way that we manage automotive, and we can apply this technology within the industry. Thank you very much for listening.
Thank you, Marcus. And you've got us right back on track as well, finishing a whole minute and 30 seconds early. So thank you very much for that. So the suspension system itself, is that ideally going to be integrated at an OEM level or available aftermarket? Or
so the goal for the suspension and the partners we're working with today is very much to go in at the OEM level. And we believe that the value and the cost of the technology means that in the medium term to long term, this is applicable within really mass volume automotive industry. Like so many new technologies, like our last speaker spoke about, starting at the high end is a great place to start. We can take a bit more risk, we can add more value, but actually the potential for this technology is in the millions of vehicles per year at the OEM level.
And in motorsport applications as well?
In motorsport application, particularly active suspension has an interesting history in Formula 1 where it was originally banned because it was too good. And this is why so many OEMs at the moment are looking to try and apply this technology. I think overall, our approach to motion control does have an application in motorsport, and we're working with a few companies in that area. But the big benefit for us is about changing the way the automotive industry can handle motion.
Perfect. Thank you very much.
Thank you.